Okay, this is a short Pythagoras video to remind you of some of the steps to solving a Pythagoras theorem problem. It's not a teaching exercise, so if you were trying to learn this from this series of slides, if you're trying to learn Pythagoras theorem from this series of slides, you'd probably be unsuccessful because I'm not going through the steps of why we do certain things or the steps of teaching individual steps. The main focus of this would be to see what you know and what you don't know, and then go back to your teacher and ask questions. So, what do we use Pythagoras' theorem for? We use it where we have a right angled triangle and we're given two sides of a triangle and we need to find the third side. So over here we have one of those problems. This is the longest side. There's an unknown here. There's two shorter sides. We're given the shorter sides, we're trying to find the longer side. In the second problem, we've been given the longer side, the unknowns on one of the shorter sides, and there's the other shorter side there. Now we can find these unknowns without actually drawing the triangle and measuring it by using a thing called Pythagoras' theorem. So there's four basic steps to a Pythagoras' theorem problem. The first one is to identify where the longest side is and where the unknown is, so what it is we're trying to find. Then we need to write down the correct formula for the situation we've been given. Then we substitute values into the formula and then use our calculator to find the unknown. So here's a typical problem. We have an unknown, it's x, and funnily enough it's also on the longest side. So I've labelled it here hypotenuse and unknown. That's the longest side there. And we've been given two other sides. So it satisfies the criteria for Pythagoras' theorem because it's a right angled triangle and there are three sides involved, one of which is unknown. Now underneath I solve the problem. I should really have an extra line of working here, so I'll put it in. C squared equals a squared plus b squared. There's Pythagoras' theorem in one of its forms. Then I've substituted the longest side into c. So instead of having c now I've got x squared. And for a and b I put the two shorter sides. So here's 5 squared and 7 squared. Pythagoras' theorem states that the sum of the square of the shorter sides is equal to the square of the longest side. So that's what I've put here. Then I've stuck these values into my calculator to get these two. 5 squared is 25, 7 squared is 49. The answer that would come out is 74. Typically you don't write that step because you just punch it into your calculator. But we don't want to know what x squared is, we want to know what x is, so we need to take the square root of this value here, which I do there, and I get an answer of 8.60 and write the units on the end because these are in centimeters. My answer should also be in centimeters. So that's the whole problem, that's what it looks like. Now let's go through the 4 steps one at a time. So step 1, identify the longest side and label it hypotenuse. The longest side is always opposite the right angle, so if you draw a little arrow from the right angle, it'll identify this as the longest side, and then we write hypotenuse next to it. Hypotenuse is just a fancy maths word for meaning longest side. And the other thing we should do is circle the unknown side. So this is the unknown side, that is the unknown variable, I have circled it. Funnily enough, it's also on the hypotenuse this time. And that is our first step. Find the hypotenuse, circle the unknown. Now once we know that, if the unknown is the longest side, write this equation here. So we're going to add the sum of the squares of the shorter sides. If we're finding a shorter side, like in this case here, we've been given the hypotenuse, but we need to find that side there. Write this equation down. A squared equals c squared, the longest side, minus the other shorter side. So what we're going to do is we're going to put this 3 over here, x will go where the a is, and the 5 will go where the c is. Let's go and have a look and see that done. So in the third step, we will substitute into our equation that we did before. We'll put the x where the c is, we'll put 3 on one of the shorter sides and 4 on the other one, and we'll get this equation here. Once we get to this step, it really is just button pushing. So then we go to our calculator, and if I do this correctly, put that line of working into a calculator. So to find the answer for 3 squared plus 4 squared, press 3, press the x squared button, press plus, press 4, press the x squared button, and press equals. What you should end up with on your calculator is 3 squared plus 4 squared, and that will equal 25. Now, once you've got your 25, we need to take the square root of it now. So press your square root button and type 25 and then put equals after it. And the answer that will come out is 5. On your calculator it should look something like this. Don't forget to put your units on the end. Then we get to the final step. Oh, that is the final step. That's the answer. We're done. Let's have a look at some other examples. Make sure we know how to do all the different cases. Here's another case looking for the hypotenuse. So where the hypotenuse is the longest side, we write the normal form of Pythagoras' theorem. There it is there. Then we substitute all the values in. Hypotenuse goes where C is. 6 and 7 go where A and B are. Stick these values into your calculator. Spits out 85. Take the square root of 85. Gives you 9.21 units. Problem solved. Here's a second question, but this time Q is on a shorter side. Here's the longer side. I labelled it hypotenuse. The unknown, though, is on a shorter side. So I'm going to use a different formula. I'll take the hypotenuse and I'll subtract the other shorter side. So the 8 goes here, the shorter side goes here. We're always going to subtract the shorter side. And Q squared will equal 48 if you punch that into your calculator. Take the square root of 48, and then this side here, if we constructed the triangle, would be 6.93 centimeters. Here's another problem, but instead of having the unknown on this side, I've put it down the bottom. So again, we label the hypotenuse, circle the unknown. The unknown's on a shorter side, so we're going to use this equation, the subtraction one, rather than the addition one. Substitute the values in. X goes where A is, 3 goes over here, the hypotenuse goes there. Punch that into your calculator, get that. Take the square, oops, that's not quite right. Need X over here. Take the square root of it, get the answer there. In fact, I might just fix that up because I've skipped a step and I really shouldn't. So x squared equals 49 take 9 is 40. X equals root 40, which is, come on calculator, what's root 40? 6.32. Okay, last one. Now with this one I've turned the triangle upside down, but it doesn't change the fact that the right angle is still pointing to the longest side. Now the longest side has the unknown, so we use the normal form of Pythagoras' theorem. We put the x where the c is, put the 2 and 3 where the a and b is. 2 squared plus 3 squared is 13. Take the root of 13, you get 3.61 units. Now, if there's any steps you don't understand, remembering this is not, I'm not trying to teach you here, I'm just trying to remind you of what you should already know. Come and see me and I'll help you with that step. Thanks guys, see ya.